Hi, this is Algebra 1, Unit 1, Lesson 1, Checkerboard Borders. We are not doing the jump start for this one. We're just going to jump right into number 1. Below is an example of the border that the administration is thinking of using to surround a 6 by 6 square of white tiles. So find the number of colored tiles in the checkerboard using this strategy. Using a strategy that either you or one of your peers might have used earlier if you were doing it. So show what you're doing. So one way you could do this, lots of ways. We don't really want to just count them. So, I suppose you could, but we don't want to. But most of the time, you want to do some sort of chunking to some degree. So there's lots of ways you might think of chunking this. And I'm actually going to go ahead and just put one of these over here. So this is that the same size? Oh, not quite. That one's a 5. Okay, so we won't use that one for this. But one thing I notice is here is kind of the width of these. And this is kind of the outline of my white tiles in the center. So when I do that, that leaves me with these 4 boxes on the outside. And then it gives me 4 chunks of boxes on the inside. And so if I think about that way, here I've got, in these guys, I've got 2 in each of them, right? So there's 4 sets of 2. And then in these guys, it's a 2 by 6, but only half of them are filled in. So those guys have 6 in them. So I have 4 sets of 6. Well, that's 24. And this one is 8. So that means my total should be 32. And I can look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there we go. I was able to do that one without just counting them directly, but I double checked myself to make sure. So the contractor who is hired to lay the tile in the cafeteria is trying to generalize a way to calculate the number of colored tiles needed for a checkerboard border surrounding a square of tiles with any dimension. So any dimension. To represent this general situation, the contractor started sketching the square below. Since he wants the diagram to work for any number of tiles in the middle square, he's just going to call side length it for the number of tiles on that square. I'm going to zoom this in just a tad on here. All right. So what do you want to do? I kind of like that chunking idea myself. So one thing you can do is this same idea we just did, right? You can look at, let's do our same colors. You're going to have corners. 4 in the corner. Now, or not 4 corners that each have 2, right? So we'll still have our 4 times 2. But the problem is we don't know how many tiles are in this little chunk. Well, if we go back to the last one, how many squares did we have? We had 12. Well, how does that relate to our length and our width, which is actually the same thing, right? Because it's a square, so both of them are the same. So let's use the same variable. Well, it was 6 across, and 6 times 2 is 12, and we only needed half of them. So however many I had across is also how many boxes I had. So if I go down here, I can say it's going to be in times, let's back up. 4 sets times n, whatever my number was that I had across. Because if it's 6 across, then there's only going to be 6 boxes. If it's 7 across, that'd be 14, half is 7, and so on. So then what did I do after that? Well, I added them together. So I had 8 from 4 times 2. 4n equals 4n. And so if I add those together, I get 8 plus 4n. So that's one way you can do it, and that's one answer you could have too. You could also chunk it a different way. Let's do it at least one more time. So that was one way. I'm going to write 8 plus 4n over here and put that as one of our answers. Now, what's another way? Well, you could also chunk it. Let's do it this way. Let's say instead of doing just the corners, let's take these guys and go this way. So this length is n, and we already determined these chunks have however many the n is, right? We already determined that. So now we have 2n, 2 times n, because this is twice as many, half of that's n, and so we have 2 sets of those. So 2n. How do I determine this guy? Well, notice if let's go up to the one above. Let's jump up to the one above. So this was 6. Well, 7, 8, 9, 10. So now we're at 10. So I'm going to have 4 boxes more than my length, right? Because if this was 8, I still have 9, 10, 11, 12. That's 12 is 4 bigger than 8. And out of that 4 bigger, I'm going to have 2 for each side, right? So going back down, this side is whatever, make the right color here. So we said it's going to be n plus 4. One, 2, 3, 4. Right. N plus 4. And I'm going to have 2 of those. So when that equals out, so when you add these together, let's just go ahead and just add them together like this. I have 2n plus 2n plus 4. So this is also an answer. Now, if I were to go to simplify this, I would get down to the 8 plus 4n. So this is kind of the simplest form of it. This is a little more complicated form, but it all works. So they're all equal. So lots of ways you can look at this. Now let's try it when our lengths and widths are different. So find an expression to calculate the number of colored tiles in the 2-row checker border of any rectangle. Now we're looking at a rectangle. So what I would do here, I'm really comfortable with the chunking with the corners myself. That seems to be pretty handy for me to be able to do. So now I've still got my 2 in each corner, right? So I have 4 corners of 2. But now I have a width and I have a length. So I actually have 3 different things going on here. Well, just like we said before, 3 boxes, I have 3 tiles. If I'd stretch this out to 4 boxes, I'd have 4 colored tiles. So whatever our W is, I have 2 of them. Let's look at the length. Same thing. If my length is 4, there's 4 boxes. If my length is 6, it's going to be 6 boxes. So I'd have 2 of my lengths. And if I were to put all these together, that's 8 plus 2W plus 2L. What that looks like is 8 plus 2W plus 2L. That's my final answer for this one. So we'll only do one example of that one. All right, so our takeaways. So what is good about all this? What did we end up learning? Well, first off, what did we do with some strategies? Well, I used color. Use color to mark the diagram and make your thinking visible. That was one thing I did to make sure that we could see what we were doing, because I had the different colors, and then I used those with my equations. Another thing I did was look for equal groups. And notice number, groups, and the size. The size of the groups. Okay, so I looked those four corners. I noticed all those four corners are going to be the same. They're not going to change. We're always going to have those four corners. And then I would look and see, oh, N's are going to be the same. The L's were going to be the same. The W's were going to be the same. Part of that, you look for quantities that are changing and quantities that are staying the same. So just like I was saying in this one, looking for equal groups, I also looked to see which part was changing, which wasn't. Those four corners were never changing, but length and width in those were changing. So I did different colors for each of those because one was staying the same, one was changing. And the last one, what did we look for? We were looking for areas. So especially rectangles and squares, right? The length times width. That's an area. We were using that information to kind of know that we knew that those would be the same. All right. Vocabulary should have gone over. That's on a separate thing. But the new ones we want to just review was equation. So we actually did not write equations up here. I'm going to scroll up here a minute. This is not an equation. This is an expression. So we'd have to have the equal sign to get that. So equivalent equations would be that you have two that are the same. Equivalent expressions, that is what we had up here. These two are equivalent. They both equaled however many boxes would be in this square, in this setup. So those are equal expressions. There's no equal signs in there. They're expressions. And a variable. Just review that a variable is our letter that we don't know. So we used L, we use N, we use W, things like that. So found those patterns, and that's really the main thing on algebra and math, is looking for those patterns and coming up with a rule to help you solve that pattern faster. Thanks for joining us today. Oh, wait, nope, just a minute. We'll do retrieval. So just another review here. Let's do the retrieval. So evaluate each expression using the given value. So this is something we're going to do. It's just kind of a review to help you get the background, review the background you need for this. So when you're doing this, you're going to have 10 minus 3. Now instead of G, I'm going to put 5. And we know if they're next to each other, that means multiplication. So what that equals is 10 minus 3 times 5 is 15 with our order of operations. And minus 15 would be negative 5. So that would be our final answer there. Here, 3 over x, 3x over 4 minus 12, x equals 8. So I'm going to put this as in a parentheses because I'm not going to write it as the fraction on here. So I'm going to have 3, they're next to each other, so that's a times. 3 times my variable, 8. And that's divided by 4. And then I'm going to subtract 12. I don't actually need my extra parentheses here because division happens before subtraction. So I know that'll be taken care of. All right, so order of operations, 3 times 8, that's 24. I'm just going to put divide by 4 minus 12. That'll all continue. Order of operations, divide. 24 divided by 4 is 6. Still subtract 12. And so final answer, 6 minus 12 is negative 6. All right. Next one, complete the table of values. Okay, so if I put in, we'll go ahead and go to the drawing tool for this one, x. So I want to substitute each of these numbers in for the x. So my first one will be 3 times 0 minus 5. And 3 times 0 is 0. 0 minus 5 is negative 5. Now I'm going to do a 3 times 1 minus 5. 3 times 1 is 3. 3 minus 5 is negative 2. Scroll up here. 3 times 2 minus 5. 3 times 2 is 6. 6 minus 5 is 1. 3 times 3 is, minus 5. 3 times 3 is 9. 9 minus 5 is 4. I'll be making lots of tables this unit. All right, next, graph the points from the table on the graph. Now remember, this is your x. This is your, well, now that looks like an x too, doesn't it? This is your y. So how do I want to do this? I have 1, 2, 3 marks. I need to get up to at least 16. If I do 3, 6, 9, that's not big enough. 4, 8, 12 is not big enough. 5, 10, 15, 6, let's see. Yeah, 6, 12, 18. So let's go 6, 12, 18. Oh, wait a minute. I'm looking at my y's. My y's need to be up to 18, not my x's. 3, 6, so I need to do my 6, 12, 18 is up here at the top. Put him in right up here. And x's only need to go to 7. So 2, 4, 6, nope, 3, 6, 9. Okay. So I'm going to go ahead and use a different color to draw this. So I'm going to put, just going to kind of do 1, 2, 3, 4, 5, 6, 7, 8. I'm pretty good at doing thirds. So 2, 4, 6, 8, 10, 12, 14, 16. So I'll know that my odd numbers are in between there. Kind of annoying since most of my numbers are odd, but it is what it is. So 1, 16, 3, 13, 5, 4, 5, 10, and then 7, 7. And there we go. There's nothing that says we need to connect them. And so that is it. And there, I believe, is the end of this lesson. So, all right. Thank you for joining us. That is it for today. Have a good one.